All right, so we're right at the start time, 1 o'clock Eastern Standard Time. So I'd like to get us started. Uh, Once again, good afternoon. I'm Jason Thomas. I'm a project engineer at America Makes, and I'll be your host for today's America Makes TRX webinar series. Little background on the TRX webinar series before I introduce our speaker and get started. As America Makes continues its mission to expand and accelerate the footprint of additive manufacturing and 3D printing, this medium called the America Makes Technical Review and Exchange webinar series was created. Excuse me. By creating this platform, it allows the additive manufacturing and 3D printing community to come together, share knowledge and experience with a broader community. If you or your team are interested in presenting during the TRX webinar series, there will be a link that I'll share. Just complete the request form at the end of our series today. Or you can contact the America Makes TRX webinar series administrator, Zane Ross, directly. Few important notes before we kick off today's series. At the end of the presentation, there will be an opportunity for a brief question and answer session. If during the presentation you do have a question, please submit it in the Q&A space on your Microsoft Teams screen, and I'll ask it during the Q&A session. We'll do our best to get all of your questions answered. Today's webinar is on bridging obsolescence, covering how manufacturers today are facing growing challenges from aging equipment, discontinued parts, and gaps in technical documentation. Without further ado, it is my pleasure to introduce Austin Meredith from BDI Additive. Austin will show how additive manufacturing and conventional machining are being used to modernize operations and reduce costly downtime. Austin is the parts replication manager at BDI Additive, a division of BDI where they lead industrial 3D printing initiatives that help manufacturers and distributors overcome complex supply chain and sourcing challenges. Austin holds a bachelor's in mechanical engineering from Virginia Tech and an MBA in entrepreneurship and innovation from Clemson University, blending technical depth with strategic business insight. At BDI Additive, they manage end-to-end parts replication projects, working across engineering, production, and customer teams to deliver custom solutions, streamline workflows, and reduce lead times. They are passionate about bridging the gap between legacy manufacturing and emerging technologies, making innovation practical, scalable, and accessible to the industry. Austin, I'm going to turn it over to you and your team now. Go ahead and take it away.
Good afternoon. Thank you so much, Jason and America Makes, for giving me the opportunity to talk about BDI and some of the things we're doing. So, Bridging Obsolescence, I picked the title of this presentation because when I started at BDI, there is a conference room at our headquarters where the walls are lined with photos of iconic bridges in cities where we do a lot of our business. And the idea there is that these represent the relationships that we're building and bridging with our customers in those specific cities. I thought that was really symbolic, especially with what we have been doing with 3D printing the past couple of years to try to continue to better serve our customers. So that's just a little background there where the title came from. And of course, as Jason mentioned, I am the parts replication manager at BDI. See if I can figure out how to advance my slide. There we go. So a little bit about BDI. It stands for Bearing Distributors Incorporated. We are a global distributor for manufacturing companies, family owned. It's been going for, I think, over 89 years now, 200 plus locations, just over 1,500 employees. So not a huge operation, but also not a small operation either. Our core products that we supply our customers, of course, in the name, bearings. We also supply power transmission components, sealing devices. And as you can see here by this list, we really anything and everything that you would need in a manufacturing environment for consumer products. The industries that we cover, again, expansive, a lot of different industries. the primary ones in green lettering: airports, automotive, food processing is a huge customer base for us, grain, flour milling, and package handling distribution centers. So where BDI parts replication and then specifically additive, BDI additive got started is a few years ago, we noticed a lot of our customers were increasingly dealing with the same issues. Supply chain disruptions. We saw a lot of customers dealing with this during COVID, a lot of opportunities come out of that. No longer available parts. A lot of our customers are running very old manufacturing equipment, and they are doing their best to keep that equipment running as well as possible. No technical documentation for a lot of these older machines, no off-the-shelf replacements, and then also just the high cost for a lot of replacement parts on manufacturing machines. And so the idea with parts replication is we utilize emerging technologies, additive 3D printing, in combination with conventional machining to be able to solve our customers' most urgent problems. Some of BDI's strengths that lend well partnered with parts replication is, as you can see on this map, we have a lot of sales branch locations. We prioritize placing sales branches very close to our biggest customers. This allows us to respond very quickly, and it also allows us to intimately understand our customers' pain points. Our technical sales team are in our customer sites regularly, and then also industry knowledge. While most of our salespeople aren't engineers, they are technical and they are definitely experts in their respective fields and industries, whether that be package handling, distribution centers, or beverage, food manufacturing. And then so going more into BDI additive, and we started BDI additive, I think about 3 years ago. Our additive headquarters is in Youngstown, Ohio, within the YBI Youngstown Business Incubator building right across the street from America Makes. And that's been hugely beneficial for us as far as being close to these important players in the industry. This first slide, though, I highlight some of our internal capabilities that we've been working on building out. We do have a lot of filament machines, and that's been a priority for us because of our customer base. It's still a very economical way to 3D print replacement parts, and there's a wide range of engineering thermoplastics that you can print, of course, on these machines. We also have some FGF pellet juggerbot machines. These are the larger, higher throughput raw materials plastic pellets. This allows us to cover bigger, more structural guards and parts there. And then, of course, the additive partnerships. This has been huge for our development. We would not be able to do a lot of the things that we do without these partnerships. It allows us to provide our customers with the biggest range of possibilities and solutions. We have a partnership with Fitz Frames, utilizing downtime on their SLS machines. It gets us some high resolution, production capable abilities there. Of course, FGF, pellet, working with Juggerbot. We've been working recently with Stratasys Engineer to see how we could use some of the VAT photopolymerization. And then DMLM, XJet, metal, ceramic, of course, working with Youngstown business incubator and America Makes. We haven't found a lot of opportunity for this with our specific customer base, but it's something that I think as the technology and the industries progress is going to be very important for us to have close by. So having these partnerships has been very valuable for us in our growth. So going a little deeper on our internal capabilities, and I know this slide is very busy, but this is really the internal capabilities strategy that we've taken in building our additive department. I've identified 4 key areas that are the most important to our specific customers, and then how we've covered that with the machines that we've put in our facility. High resolution, medium and large format parts, cost per part, and honestly, the cost per part is probably the most important one for our specific customers. And then also the high temp, high strength, and we're seeing more and more of that, especially in the food and beverage industry. But you can see we've been utilizing primarily bamboo and Prusa machines to be able to cover that cost per part, but then also starting to get into the high temp, high strength there as well. So the majority of our customers are food and beverage, and of course, additive 3D printing definitely has some challenges as far as food and beverage. As you all know, depending on the technology, additive is going to leave layer lines across your part. When it comes to food and beverage, these can trap bacteria and be very difficult to clean. We have been doing a lot of development internally here to be able to better serve our customers. We do print with a lot of FDA approved raw materials. We've been working with a supplier on some metal detectable nylons because that's a huge priority in a lot of food manufacturing environments. So most of our successes so far in the food and beverage industry we've been calling it indirect contact parts. And these would be parts that aren't directly contacting food, but they might be in a packaging area or a different part of the manufacturing process. We are currently working on the metal detectable FDA approved material, but then also with a supplier to vapor smooth that specific material. So the idea there would be the raw material is certified, the vapor smoothing is certified, the final part is a watertight, smooth, food safe part. So we think that's going to be a big deal for a lot of our food customers. And then I wanted to touch on the machining fabrication capabilities as well. We have a vast network of machining and fabrication shops specializing in anything from CNC milling, turning, casting, forging, injection molding. We have our own gear shop in Akron, Akron Gear. And so a lot of different technologies that we have access to there. And so when we're talking to customers, we really pride ourselves in being able to look at their problem and say, okay, additive machining, maybe a combination of both, what's going to be the best possible solution for them? And so I'm going to take the next few slides to go into some successes that we've had. This first one is an obsolete OEM part for a flour milling dust collection system. The original part pictured on the top, no longer available from the OEM. we were able to take that part from the customer, 3D scan it, quickly prototype a couple iterations, and get them pictured on the bottom there, a working 3D printed carbon fiber nylon replacement. And we've been able to continue supplying them with those. I think at this point, well over 400 units so far. So that's been a really great one where they had no other solution at the moment. I really like this one because it seems like such an inconsequential part, but it led to some huge savings for our specific customer. The 3D printed part is in red in the photo on the right. And this was simply a custom bracket we designed to be able to mount a new proximity sensor in the top of this valve. These are mix-proof valves used in a lot of dairy and brewing applications. And what it was our customer was trying to keep their old valves in service. Their old valves operated on 120 volt controls. New valves would operate on a modern 24 volt DC PLC. The new valves, though, had different style fittings. And so to upgrade their old valves, which were still working, to new valves, they would have to repipe everything, not to mention the cost of the actual valve. And so we were able to really quickly take the top of one of their valves and design, and then the same day 3D print a bracket to hold a 24 volt prox sensor in the top of the valve, exactly where the old prox sensor was. And that let them keep all their old valves in place while upgrading their control system. Saved them so far close to $350,000, which was they were absolutely thrilled with that. And it was just such a minor, small 3D printed part. But I'm not sure how we would have honestly done that without 3D printing. This is another unavailable part. This was for a fulfillment warehouse. It's a pick to light sensor button. This is where the operator hits the button as they grab the product to go into the box to the customer, the end use customer. The OEM would not sell just the cover for the button. So we were able to take the original cover, 3D scan it, and get them a replacement in PA12 nylon. The replacement was more durable and stronger than the original, and the cost was much less, saved them 82% over replacing the entire button unit. And we've been able to stock these locally at BDI sales branches so that they have them on demand when they need them. And this one working with a bottling facility. The machine that you see pictured there is a mandrel sleever. It guides the shrink wrap sleeves onto plastic bottles, the assembly pictured on the bottom there. What was happening here was they were having issues with the current parts. It's 4 plastic white parts that guide the sleeve onto the bottle, and then 4 matching metal springs. All of the parts were very high cost replacement parts, and they also weren't honestly working very well. This is one where combination of both 3D printing and machining, we're able to 3D print the plastic parts, but then also laser cut some new springs. We also went in, took some measurements, and made some modifications to the springs and got them with both additive and machining, longer lasting parts at over 90% savings to the customer. This one working for a replacement motor coupling cover. The original part on the left, these were actually breaking as the customer was installing them. I believe this was at a flour milling facility. But you can see as a brittle plastic is a single piece design. So they would have to take apart the motor shaft to get the cover on, and then put everything back together. So this gave us an opportunity with Additive to change the design, make it a split two-part design. They no longer need to take apart the motor shaft. They can fit it around it. And then we also made it a lot more durable. We made it thicker. We used a carbon fiber nylon, and provided them a much better part than the original, much thicker and stronger. And we've seen a lot of new opportunities come out of custom machine guarding and safety devices, actually. This is a custom e-stop guard. We actually are using fabricated metal brackets for this, but we went with a safety yellow half circle ABS for the actual guard for the e-stop. What's happening at this facility is pallet jacks, forklifts were hitting the e-stop and actually breaking it. They wanted to guard it. They didn't want to obstruct access to the e-stop. And the previous guards that they had come up in-house with were all metal. They also didn't want to do any serious damage to equipment in the case of a major collision. So we went with the safety yellow ABS. And it was actually really interesting because the material choice there, that when the ABS failed, it failed very specifically along the layer lines, allowing the guard to somewhat retain its shape, but at the same time absorb the impact, and keep the e-stop safety equipment from getting damaged. And they have a ton of these throughout their facilities. So we're working on hundreds of them right now to outfit all of the e-stops. And this is another custom design, a end of arm tooling for a food manufacturing facility. And they were having debris getting sucked up in the vacuum of the end of arm tooling. So we helped design a custom screen to go inside of that, keeps any debris from getting sucked in. And we printed this with a flexible TPU. So this helped them a ton in reducing production downtime specifically. And then this one is definitely more machining, but it was older brushes for an oil separator in a corn processing facility. The original pictured on the top left, our BDI replacement on the right. And so we were actually able to fabricate a metal bracket and then source through one of our suppliers an off-the-shelf brush and get them something that was going to be just as effective for their older equipment, but also off the shelf, a whole lot cheaper, and resulted in over $100,000 annual cost savings for the specific customer. So they were thrilled with that. And so through all these examples, adding additive to our parts replication capability and growing that has really enabled us in working with our customers to respond faster. It's helped us save our customers a ton of money, and then also, as you've seen, innovate designs and create custom solutions. So a lot of what I end up doing in my role is working with our sales force in helping them identify opportunities. So our sales force is very knowledgeable, but they don't know a lot about 3D printing. And so one of the issues initially there was when we would go in to talk to customers, a lot of that conversation was driven by our specific capabilities. We can print this material, we can print parts up to this size. And it was really giving us tunnel vision as far as what we were looking for in helping our customers. We found a much better approach, at least for us, has been to not, on that conversation, not worry about our capabilities. Go into the customer, open mind, focused on the customer. What are they having problems with? Identify their biggest pain points. And then from there, we start to bring in additive to the conversation. And we say, okay, these are the problems, these are the pain points. Is this something that additive's going to add value? Whether it's faster, saving money, innovating. If using additive is going to add value, that's great. But we don't want to use additive for everything. So if it's not going to add value, if we're going to be forcing it on something, we have a lot of other technologies. So that's kind of the key question there. And then just looking forward, future outlook for BDI, parts replication, growth. My previous experience actually before coming to BDI was in metal additive with GE gas power. I think that there's going to be a lot of opportunities for us in the future in metal additive right now for our customers, because we don't have really any military customers, any aerospace. Our customers are food and beverage, consumer products. We're not right now seeing opportunities for metal additive. And the main point there is it's very expensive and not super accessible right now. But I think that's going to change. And that's something that, we want to definitely keep a close eye on as metal gets cheaper and more accessible. What opportunities and problems is that going to help us solve for our customers? The food safe issue is a big one for us. I think silicone 3D printing, I know there's definitely some people working on that in the industry. Once that becomes more widespread, that is definitely something that we will be jumping on. And then also just, our internal capabilities, of course, adding technology where we see it can fit with our customer needs. And even just in the couple of years that I've been at BDI, I've seen changes in how additive stacks up against injection molding, because we'll also quote injection molding. And we've seen a couple opportunities where we've actually started to look and say, do we actually want to 3D print this versus injection molding? And I think, as everything changes, that question, that competitiveness there is going to develop. And that'll honestly only help us better serve our customers. So that wraps up my presentation. Thank you everyone so much, and I'd like to open it up to any questions or discussions you might have for me.
All right, thank you, Austin. We'll now go ahead and head into the Q&A session. If you have any questions for Austin and you haven't done so already, please go ahead and type it into the Q&A box. If chat works better for you, go ahead and put it there, and I'll pull it out. So I guess the first question is, Austin, so in your work and dealing with all these different industries, which industry do you see as most acceptable, or that I guess is most willing to use additive? Are they all pretty much the same, or do you see one that's kind of ahead of the curve?
Yeah, that's a good question. And of course, even though we're in a lot of industries, we're not in everything. I think for us, the one that's been most accepting has been automotive. Um, and that's I didn't have anything in here specifically on that, but that's kind of opened up a different conversation with our customers where a lot of our automotive customers already are getting their own additive. And so we work with them to see, okay, what can we do to supplement what you guys already have? So automotive has been very, very receptive to additive. And if I can add on the other end of that, the probably the least receptive for us specifically has been the food and beverage, specifically because of the safety issues there.
That was going to be a lead up question. Was I think because of the porosity, maybe it would be, and like you said, the layer
Hmm.
lines
Yeah,
that could cause some issues
exactly.
there. Okay, that makes sense. That makes sense. Thank you. All right, so I don't see any more questions coming in. I'll go ahead and give it another second here, see if we have any come in. So you must have done a great job on that presentation, Austin. It was very
Gosh, I hope
detailed,
so.
a lot of information there, so thank you. Really appreciate it. So
Of
do you
course,
think with
thank you.
I've seen a lot of the silicone printing too at different shows and things I've been to. Do you
Hmm.
think that'll open up more opportunities in the food industry and maybe the medical industry as well
I
as that
do.
progresses?
Um, I really do, and that honestly is something I don't know a lot about. There was a We played a little bit with thermoset printing at BDI, just using two-part thermosets. We had some struggles there with getting the geometries we needed, and we just didn't have the resources to become a thermoset R&D facility. But yeah, no, I think the silicone, because if you go into food and beverage facilities, there's already a lot of silicones. It's just such a good material, very resilient, very high temperature resistant, food safe. I think there's going to be a ton of opportunities um, once there's more accessible silicone 3D printing that can do more conventional geometries.
Okay. Thank you. Oh, we got a couple that came in here. All right. So, let's see first one. What 3D scanning technologies are you using?
Yeah, so we're using an RTEC. I think it's the Space Spider right now. That's definitely our primary 3D scanning technology that we've been using.
All right, thank you. And then let's see, follow up on the DoD clients that you mentioned. So have DoD clients been something you haven't pursued or you just haven't seen interest from them?
Um, Honestly, it's not something that we've really pursued. And from where I'm coming from, we started the parts replication additive about 3 years ago. BDI just already outside of DoD had such a vast customer base that we just weren't tapping into at all. So we had so much and still do have so much to work with that. I would love to pursue some DoD, but right now we've kind of had our hands full with our existing customer base and then have had no shortage of business there.
Oh, that's great to hear. That's really great to hear. All right, so I don't see any other questions coming in. Let me just check the chat quickly. I don't think no. So I think that's gonna do it for us. So I'll go ahead and close us out. That'll wrap up today's TRX webinar series. I would like to thank Austin once again for that very detailed presentation. If you do have further questions for Austin, please reach out directly at the email that he has here on the screen. So we really do appreciate the time that you take to provide America Makes feedback so that we may continue to improve and strengthen the additive community. So feel free to always send that in to us. And as a reminder, if you or your organization would be interested in sharing on the TRX webinar series, please follow the link that I dropped in the chat there, and you can fill out the presentation request screen, or you can reach out to Zane Ross directly. Austin, thanks again. Everyone have a great day.
Thank you, Jason.